Hey guys, Dr. Brown here, and tonight we're working an integration problem, the integral of dx over the square root of 2x minus x squared. If you follow the channel, you know the tools we use. U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and method of quadratics. So those are our tools. So when we look at this particular problem, we can see that, well, we have this quadratic in the denominator, so completing the square becomes a tool I would try to use first. Okay? I mean, you can look at U sub, trig sub. At the moment, no, maybe that doesn't work for you. So let me pull this out of the denominator and work with it here. I've got minus x squared plus 2x. I'm going to pull the negative out. So that's negative times the parentheses of x squared minus 2x plus something minus something. Okay, we'll put that parentheses right here. Now obviously the negatives time all of this. Now when you're looking at completing the square, you have the a term, the b term, and the c term of a quadratic. So I have a negative 2, and by the way, you take the b term over 2 and square it, and that becomes what goes in the box. And if you add that, you have to subtract the same thing, keep the same relationship. So in this case, we have negative 2 over 2, and we're going to square that, so that's negative 1 squared is 1. So we're going to add 1, subtract 1. Okay? Now, to figure out this, we really just factor this. We're taking the square root of the first term, which is x, the square root of the last term, square root of 1 is 1, and we keep the sign of this, the term that we just used in the calculation. So if this were a plus, I would put plus. Since it's a negative, I'll put negative. So that's x minus 1 parentheses squared. Now it has a negative sign in front of that, minus all of this. Now minus this negative 1 gives me a positive 1. So I'm going to flip this around. 1 minus the parentheses of x minus 1 squared. Hey, so now we have the integral of 1 over the square root of 1 minus the parentheses of x minus 1 squared, integrating that with respect to x. Now, when you look at this term, and you guys probably know this already, but when you're looking at whatever this might be, it could be 9 minus x minus 1 squared or some other number other than 1. But when you're looking at that, you're looking at things like 1 minus sine squared, that equals cosine squared, theta, let's say. Okay, I could have 1 plus some term, and if it had, 1 plus something, now I'm looking at, well, maybe that's tangent. Okay, if it's if it's some number minus something, that's not a 0. We'll put a different shaped box there. So now if it looks like this, well, maybe that's secant. Okay, so you can look at the shape or the form and get a feel for, based on your trig identities of sine, cosine, tangent, secant, those guys, and that's what we're going to do here. To me, this looks like a sine function. So I'm going to let this term be a squared equals 1. Now obviously a equals 1. Now some people will write me and say, if it's 1, why are you going through and doing this process? Because no matter what number it is over here, if you follow the same process, you'll end up with the correct terms. The a only divides out, in this case where it's 1, it drops away. I get that. So please don't write me and say, why did you go through it like this? It's so no matter what the numbers are, the process to solve it will be the same. Okay? All right, so x minus 1, we're going to let that be a sine theta. So if I take the derivative of both sides, derivative of x is dx, derivative of 1 is 0, so dx equals, the constant multiple rule of derivatives, so I can pull the constant out, a times the derivative of sine, which is cosine theta, and then derivative of theta is d theta. Now, what do we have? Let's fill in the blanks here. I have dx is now replaced with a cosine theta d theta over the square root of a squared, which is 1 squared, minus x minus 1 squared. So I have a squared sine squared. Yes, and I know there are ones, I get that, but the process is the same here. All right, so we have the integral then of a cosine theta d theta over, I'm factoring out the a squared term, square root of a squared times 1 minus sine squared theta. Okay, all I've done is factored the a square out. Okay, so now square root of a squared is a, so that term in this one will divide out. 1 minus sine squared is what? It's cosine squared. So I have the integral of cosine theta d theta over 1 minus sine squared, the square root of that actually, square root of cosine squared theta, and the square root of cosine squared is cosine. So cosine divided by cosine, those divide out. So I'm left with the integral of d theta. So it just becomes theta. So theta then would be the sine inverse of x minus 1 over a. Sine inverse of x minus 1 over a. Of course, we know a is 1. I'm going to go ahead and write it there because a could be 9, 12, 14, whatever it happens to be. All right, but now I'll erase it, plus c. Okay, so sine inverse x minus 1 plus c. That would be, my friend, the integral of dx over the square root of 2x minus x squared. Using two tools here, we use completing the square, and then we did use trig sub here. So that would be a simple problem, how to use completing the square and trig sub. And by the way, it allows you to end up with one term down here in the denominator because there may be a complex problem in the numerator. And if you can get one term in the denominator, hey, it works out easier for you. Why are we doing this? Together, we're trying to build a better tomorrow and do that through math. We'll talk to you next time. Keep studying. Thanks.